Okay, so this is starting Unit 2. This is going to be Lesson 2.1. So you can put that in the topic, 2.1, Graphing Quadratics. Does anybody know what the word quadratic means?
I think I know what quadratic.
A quadratic is any polynomial that's raised to the second power. So like x squared, y squared, that's called a quadratic. Okay? Oh, sorry. All right. So the standard form of a quadratic equation looks like this. We're going to use f of x. Now, this is really just a fancy way to say y, okay? F of x really just means y, but it stands for the function of x. And we're going to talk a lot about functions in Algebra 2, so we're going to change the notation. Instead of writing y, we're going to write f of x. So f of x equals ax squared plus bx plus c. This should look familiar a little bit to you. Based on factoring, we did the ax squared plus bx plus c. So this is the standard form of what a quadratic equation looks like, okay? When we graph a quadratic equation, it creates a U-shaped curve. Does anyone know what that's called? Thank you, Ryan. It's called a parabola. Not a parabola. But a parabola. Okay? So these are some vocabulary things right here. So a graph, standard form, etc. So now it says use your graphing calculator to sketch the following. We're going to put a pause on the graphing calculators, okay? But if I were to graph this first example, it's going to look something like this. Okay, so go ahead and sketch this parabola. This parabola is opening to the top, or it's opening up. Does anyone know why the parabola is opening up? What's positive? The thing is positive, okay? The x squared, right, the variable to the second power, this variable right here, if it's positive, it's going to open up. So just like up top, guys, we had that ax squared plus bx plus c, right? We had that up top. If the a value is positive, then the parabola is going to open up. So let's write that down there. If a is positive, the parabola opens up. Like a smile. You're happy. You're positive. So you're smiling. That opens up. Okay, there are a couple things on this graph that we need to talk about. First of all, we have something that cuts through the middle of the parabola. Does anybody know what this thing is called? The axis of symmetry. Good job, guys. So the axis of symmetry, okay, is a vertical, we're defining it down here. It's a vertical boundary line sorry, you can't really see it. It's where you have axis of symmetry, there are a couple lines there. I'm sorry, Rebecca. A vertical boundary line that divides the parabola into two equal parts. That divides parabola into two equal parts. Then we also have on our graph we have this thing, this dot right here. This is called the vertex, and we'll define the vertex in just a second. Go ahead and draw your dot with an arrow to it. That's called the vertex. All right, so if we know that when A is positive, the graph opens up, look at that second example there. The A value is what? Negative. So what do you think the parabola is going to do? It's going to open down. Okay, so we're going to draw a parabola that opens down. So we know that if A is negative, that's going to be your next blank there. If A is negative, then the parabola opens down. Let's go ahead and draw the axis of symmetry on this graph. It's a dotted line because it's kind of imaginary. And let's go ahead and put our vertex here. So if A is positive, it's going to open up. If A is negative, it's going to open down. So the other little thing to talk about is we have these things called minimum and maximum. Do you guys agree that this vertex over here, that's the lowest point on the graph, right? Your graph is going like this, and this down here, that vertex is the bottom point, right? It's the lowest point. So this graph would have a minimum. So if the graph opens up, it has a minimum point. And then what do you think about the graph that opens down? Do you guys agree that, again, this is still, that's the highest point the graph is ever going to get, right? So what's the opposite of minimum?
Maximum.
Good. So this would be a maximum point here. Okay, any questions about that so far? This is fun? Yes. Gold stars for you, Ashley. Okay. All right, let's move on. And it says the formula for the axis of symmetry. So the axis of symmetry is a line, and every line we have in math is always connected to a graph, right? Every line we have is connected to a graph. So right here when it says the formula for the axis of symmetry, x equals negative b over 2a. Where do you think a and b are coming from? Where do you think a and b are coming from? Where do you find those numbers?
In your quadratic equation.
In the standard form, right? Leanna's saying up there in the top where it said ax squared plus bx plus c, that's where this a and b is going to come from. Now it says negative b, but what it really means is the opposite of b. So if b is negative, you're actually going to plug in a positive. Okay, so you're doing the opposite of b. All right? So to find the axis of symmetry, you're going to do x equals negative b over 2a. Okay? The vertex is very closely related to the axis of symmetry. If you guys look at the graphs, it's off my paper, but if you look at your graph, do you notice that the axis of symmetry goes through the vertex each time? You guys see that? Or it should on your paper at least. Okay? It's because to find the vertex, you're going to start it exactly the same way. The vertex is also started with x equals opposite of b over 2a. And then you plug in x.
Can we write
Yep.
the opposite of...
To find y. Yeah, these are your notes. So whatever you need to do on your notes to help you remember is fine. So to find the vertex, we start by doing opposite of b over 2a also. Okay? Plug it in to find y. They use special letters in Algebra 2 to represent the vertex. It's an x, y point, but they use the letters h and k. So h and k correspond to an x and a y. It's just really important, so they used h and k instead. But it just means x and y. They're really important x and y. So we already talked about when the vertex is the lowest point, it's called the what? When it's the low point, it's called the minimum. When it's the high point, it's called the max. And you can abbreviate min and max, that's fine. We're not going to worry about this example on here because we're going to do 4 examples on the back side. Okay, so let's flip over to the back page, or the back of this page. We're going to do some examples. I'm sorry about the copying that line at the top of your page. Something is wrong with our printer. It says, find the vertex, the axis of symmetry, the min, max, and the y-intercept of the following equations. That seems like a lot of stuff to find. Okay? So we're going to take it a step at a time. The first thing to do, always, is to find the vertex. So put vertex number 1 over here. And you find the vertex by doing opposite of b over 2a. That's how you get started. Taylor, did I give Aspen a packet?
Yes.
Okay. All right. All right, so let's look at number 1. You have some space down below to work. I want you to use this space over here to write your final answers, okay? So we're going to use that space over there to write your final answers. So below the graph is where we're going to find the vertex. So we're going to start by doing the opposite of b over 2a. If you need to label your problem, you can do that. A, B, C. So what's the opposite of b here?
So basically we divide 16 over 2.
Well, we're getting close. So we're going to plug, negative 16 is my b, right? But so when I plug it in, I need to plug in a positive 16. Divided by 2 times, what's the a value?
2.
2. Okay. So this is really 16 divided by 4, which is what?
4.
4. Okay, so what I did just there is I just found the first coordinate of my vertex. I found that h value. What else is related to the vertex, though? What did I say are related, those two things?
Axis of symmetry?
The axis of symmetry is also related to the vertex. So when you find the first coordinate of the vertex, you've actually already found the axis of symmetry. Remember we said the axis of symmetry is a line. So it's always x equals 4. It's an equation. So make yourself a note over here that the axis of symmetry is always x equals something. It's not just the number by itself. If you just tell me that it's 4, you're going to get the problem wrong. Because an axis of symmetry is a line, and every line has an equation that goes with it, not just a number, right? So your axis of symmetry is x equals 4. Okay, who remembers how I said to find this y value or the k value? Does anybody remember how I said to find that? Plug in our x value, okay? So we knew that our x was 4. So we're going to plug it in up here to this 2x squared minus 16x plus 33. We're plugging 4 in for the x here and here. Okay? So I'm going to do it down below the graph. So I had 2, but instead of an x squared, I'm going to put 4 squared and then close your parenthesis. Put the square on the inside. Okay, so all I'm doing is plugging 4 in here, and then I'm going to plug another 4 in here. So I have minus 16 times 4 plus 33. Now you all have calculators, so we can multiply this out. Follow your orders operation. Everyone has their calculator. Everyone should be working this out, not just watching. Don't skip steps, please. I got positive 1. Did anyone else get positive 1?
I was
Okay.
looking at the math, but I probably won't miss that.
When you are doing your vertex, you should not get a number that's greater than like 7, okay, or 8. So if you're doing this and you get like negative 52, you've done something wrong, okay? All right, so let's go ahead and fill in the 1 up there on step number 1. My vertex is at the point 4, comma 1, okay? So I found the vertex and I found the axis of symmetry. What else is it asking us to do there? At the top?
The minimum and maximum.
It says find the min and the max. Okay, so I'm asking you, does it have a minimum or a maximum? Well, how do we tell if it has a minimum or a maximum? We look at which number? The first number, the A value. If it's positive, it's going to go up. If it's negative, it's going to go down. So let's look at this one. We have a positive 2 as our A value. So this one's going to do what?
Have a maximum.
Okay, let's think about it. It's going up.
Minimum. It's all the same.
If you need to do it this way, right, draw yourself a little parabola. Oh yeah, it has a low point, okay? So it has a minimum. And step number 4 says to find what?
The Y-Intercept.
Okay, so let's make a little note over here. Number 3, we're doing the min. That's if it's going up. The maximum is if it's going down. 4 says to find the Y-intercept. If we're trying to find a Y-intercept, remember it's on the Y-axis somewhere. And if we are on the Y-axis, you don't need to draw this, I just want to show you something. If I'm on the Y-axis here, anywhere along here, this is the point 0,4, this is point 0,2. What's the X value no matter where you are on the Y-axis? 0, right? So we know if we plug a 0 in for the X's, we can figure out what the Y-intercept is. So if I look back at my problem and I were to plug in 0 for my Y, look what or my X, I'm sorry, look what happens. If I plug 0 in here for X, that term turns into 0. If I plug in 0 for X times negative 16, that turns into 0. So what's the only thing that's left?
33.
33. And that will happen every time. Okay? So whatever your C value is, that's always going to be your Y-intercept. So down here where it says Y-intercept, let's put 0, comma C. So you can remember, oh yeah, I just take the C value. Okay, so I have my Y-intercept is the point 0, comma 33. Now, are you actually going to be able to graph 0, comma 33 on this graph? No. So if you can't graph it on your graph, that's okay. If you can, go ahead and do it. All right, so now let's go ahead and graph. So we're going to graph our vertex first at 4, 1. So that means I'm going to go over 4 on my X and up 1. And we know that our parabola opens which direction? It goes up. So I'm just going to give a rough sketch of what this looks like. I'm going to label my vertex with a V, 4, comma 1. What else might our graph need? Our axis of symmetry, right? So we're going to do a dotted line, and I know it's hard with a pencil to do it, so just do your best. And your axis of symmetry should go all the way from top to bottom with arrows on top and bottom. And somewhere along that line, you're going to label it x equals 4. Anywhere along that line, you're going to equal it x equals 4. So whether it's at the bottom beneath it or above it, x equals 4. Okay, that seems like a lot of work for one problem, but you're going to go quickly through it, okay? So let's try number 2. The first thing we're going to do is find our vertex. Okay, so when we find our vertex, how do we start that?
negative 4 times
What formula are you using, Crystal?
negative b over 2a.
There you go. Okay, so start with your formula. I want you to write your formula down since you're just now learning this. Even if you learned it with Miss Carolyn, it's been a while. So I want you to write it down, please. So negative b means our 4 value is positive, right? So when we plug it in, we're going to plug it in negative. 2 times, what's our a value here? No, it is not 1. It's negative 1.
It's 2, actually negative 2. Because
Okay, when you listen to my question, your a value, not what is it after you multiply it. What is the a value in the problem?
Oh, 2.
No, the a value in the problem is right here. That's a negative 1 up top.
Oh.
Okay. So we're plugging in a negative 1 for our a value.
You don't do the opposite on that one?
Nope, do not do the opposite on the a, just on the b. So negative 4 over negative 2 is
2.
okay, so there's the first coordinate of my vertex. What else did I just find? Give me a little more than that. Not just x. You found your axis of symmetry, right? Whenever you find the first coordinate of your vertex, you've also found these are the same. These are the same every time. Okay, now how do you find that second coordinate of your vertex? Someone besides Crystal. John. Plug what back in? Okay, now hear me very clearly. When there's a negative x squared, I want you to do this. Put a negative 1 out front first, and then put your 2 squared. Okay, so put a negative 1 out front to represent that negative x squared. Because some students might say, oh, that means I'm going to do negative 2 squared. And that's going to give you the wrong answer. So if there's a negative out front, make it a negative 1 first, then put your 2 squared inside. Plus 4 times 2 minus 5. Okay, solve that out, please. Please notice how organized my paper is. Your paper should look almost the same as far as like labeling things down the side. Mm-hmm. So I'm plugging 2 in here for my x, right? And there, instead of making it negative 2 squared, because that would be incorrect, that's really a negative 1. So that's why I made it a negative 1. And then that negative goes away, and now I'm just plugging 2 in, and I'm squaring 2.
Okay.
Yeah. Okay.
I believe that should be negative 1 as our final answer.
Okay, did you check with any of your table mates to see if they got the same thing? This should be multiplied, negative 1 times 4. So negative 4 plus 8 minus 5 gives you negative 1. So negative 1 is the second coordinate of our vertex. Go ahead and put that up there. Step number 3, does this open up or down? Olivia, what do you think? Up or down? How do you know whether it opens up or down? What do you look at? You look at the A value, remember? Not your vertex, but you're going to look at the A value in the beginning. And so your A value up here is what? It's a negative 1, right? And so if it's negative, what's your graph going to do? It's going to go down. Yep. Okay, so we know it's going to go down, and you can even make yourself a note that it's going down. If it goes down, is it going to have a minimum or a maximum? Maximum, right? And then who would like to give me our Y-intercept? Leanna? Not just negative 5. 0, comma, negative 5. Remember, it's always whatever your C value is. That's your Y-intercept. Okay? All right, so now we're going to go ahead and graph it. So I have everything I need. Let's go ahead and graph it. Make sure you label everything correctly. I'm so sorry these graphs look so gross. Are they pretty faded on your paper too?
Yeah.
I'm sorry, guys. I'll fix that for next time. I know, he's having a great time. And you're just going to make it go down. Your parabola should stretch to the bottom of your graph. I'm not looking for any baby parabolas that only take up a part of the graph. Your parabola should stretch all the way down. It should have arrows on the ends of it. You can just make it a solid circle.
How do we graph our Y?
Okay, we'll talk about that in just a minute. Okay, what else do I need to add on here?
X equals 2.
My axis of symmetry, right?
I don't think my parabola kind of matches the diagram, but hopefully.
Does it go through 2, -1? This should be the top point, and from here you should go off to the side, not up.
Oh.
Okay. So then make sure that you label it x equals 2. And now, Leanna asked a good question. She said, well, what about the y-intercept? Is 0, -5 on your graph? Can you graph 0, -5? You can, right? So we're going to maybe erase this side here. I'm going to put a point at 0, -5. And then I'm going to make my parabola go through it. Okay, you don't need to label it. I'm just going to make my parabola go through it because the y-intercept is there. Yes, you will get graded on the graphing part. And if you leave off vertex or if you leave off axis of symmetry, you will get points off. Yeah, that's fine. Okay, let's try example number 3. I want you to try it on your own. We've done 2 together. You have a list of things you need to do. If you're watching the video, go ahead and pause and do number 3. Here's the graph. Go ahead and check your work. Pause and check your work. Okay, most of you are getting finished. It's easier to plug in when the x value is positive. 2 squared minus 4 times 2 plus 1.
Okay, so wait, on this graph, never mind. I'm
Who else got their vertex to be 2, -3? Your vertex is 2, -3? Okay. What happened? You found 2, okay. 4 minus 8. Oh, this is a 1, and all of a sudden you made it a 4. So just a silly mistake. Your process is right. 4 minus 8 is -4. -4 plus 1 is -3. Is this graph going to open up or down, Mitchell?
It's going to open down.
How do you know?
It's going to be up.
Okay, because the A value is positive. Good. And if it opens up, Mitchell, is it going to have a minimum or a maximum?
It's going to have a minimum.
Good. A minimum. Okay, my y-intercept. Ben. What's the y-intercept here? Ben. So you can say, I'm not sure yet. That's a better response. Rebecca, help him out. 0, 1, right?
0.
Are we going to be able to graph 0, 1 on our graph?
Yes.
Okay, so let's go ahead and make that dot there, that point there, so we don't forget as we're graphing it. So we're at 2, -3. We're labeling our vertex. Oh. Yep, label your vertex always. Then we have our axis of symmetry. X equals 2. Okay. How you feeling?
All I have to say is this all we're doing for homework? Is this so?
You have 3 days to catch up on, so you're good.
Yeah, I mean, not me in particular.
Yes.
I mean, but tonight's homework going to be
No. Yeah, this is exactly what you're going to do tonight's homework.
Okay.
Considering I used to do
But I'll have-
quadratic formulas to solve some of the problems of Algebra 1,
We're doing that on Wednesday.
awesome. I actually like doing quadratic formulas.
Okay, I'd like you to look at your packet, please. On page 3, in your packet on page 3, it says homework 6 at the top. You have 4 problems to do, and it should be modeled just like we did in our notes. Do you see it? And again, in the purple box, this is what I'm looking for in this box. On your 1, 2, 3, 4, the format looks exactly the same as your notes. Okay? So we need to do homework 6, and before you begin, look at your Unit 1 packet, please. Unit 1 packet. The last page says factoring mixed. It says homework 5 on it. The very last page of your packet says homework 5. That must be done front and back. So you have homework 5 and homework 6 tonight. Your factoring packet is due when? Wednesday. When is it due?
Wednesday.
Factoring packet has to be done Wednesday, or you get 0 credit. If you are absent on Wednesday, you should probably make sure you walk to school and slide it under my office door so that you get credit. Okay? We're going to have a factoring quiz on Wednesday as well. All right, so factoring needs to be done. All of the factoring videos are on YouTube. You're welcome to hop on there and look at them. We have 45 minutes of class time left. I expect you to be using that wisely to get homework 5 and 6 done. I don't care which one you start on, but you need to be on homework 5 and 6, please.